2 plus B2. U1 is how much? 3. I am in my first equation. You need to work together with the two equations. It's called simultaneous equation. So what is U2? 0. Equal. What is B1? 0. B1 is 0? We don't know. That's what we are looking for. B1 plus B2, we don't know. On the second equation, U1, how much? What is B1? We don't know. Equal U2 0. And plus B2. Is that right? Since I have two unknowns, I have to solve the system of equations. What I will do, I will bring this B2 to where? Substitution method, where I will substitute? Into this equation. So I get the 3 plus 0 equal to what? B1. B1 plus 3 plus B1. Is that correct? What will happen with this 3 and 3? They cancel out. I move the 3 to the side and I get 0 equal to what? 2B1. And what is B1? 0. And now I go back to here and I substitute. What will be B2? That's what I want to prove. That was what I want to prove. This. Which is what you saw here. So, if you have this, right? You can see this here. This was what I proved. If I ask what is the kinetic energy final, what can you do? You can, now I have both. But if you don't have both, and with this information, I can find the kinetic energy final, because the kinetic energy final and initial are the same. This is elastic collision in one dimension. Example. The study guide everything that is elastic collision has to say explicitly elastic collision. So what problem do you think in the study guide? Read it and tell me which problems are elastic collision related. 11. And what else? 12. Can you see that? Good. 11, 12 are examples of those. This, you will use this theory on this. Of course, not always the masses are the same. For example, in 11, I said a 3-kilogram object moving in the positive x direction has a one-dimensional elastic collision with a 5-kilogram object initially at rest. That situation is this one. What is heavier, the first or the second? The second is heavier. This. This situation. This is lighter. This is heavier. So the question is, a 3-kilogram object moving in the positive x direction has a one-dimensional elastic collision with a 5-kilogram object initially at rest. After the collision, the 5-kilogram object has a velocity of 6 meters per second in the positive x direction. Look, after the collision, this has a 6 meters per second in the positive x direction. The question is, what was the initial speed of the 3-kilogram object? Now I don't give the speed of the initial one, I give the final one, but it's the same idea. So this is the situation. The momentum didn't conserve because there was an external force acting. You can see the external force was not equal to 0. There was friction. Momentum didn't conserve. Right? But if there is no friction, this is what have to happen. Okay? So this is moving to the right with 6 meters per second, and this is moving to the left. We need to find what will be the velocity of this, and this have to be a negative. So let's do it. So set it up, the problem. set it up the problem and use the simultaneous equation. You need to find that the second velocity is negative.